Hello and welcome to this video on the fundamentals of engineering mechanics. Today our topic is force, the most important concept in mechanics. Can you imagine a world without movement? Boring. In our world we see people and things moving or being moved from place to place. By this I mean you always find yourself in a position to lift a book, to take a cup of water, to breathe in oxygen. That's movement. And this is all possible thanks to forces. In the previous video you were introduced to mechanics. This time you will learn about forces, the most important concept in engineering mechanics and the physical world. Let's get started. At the end of this video you will be able to explain the following: force. You will also be able to know the unit of the force called Newton. You will be able to know what it actually means. And then we will be seeing the properties of forces, their effect on bodies, and then we'll see the classification of forces and the component of forces. So let's take some basic definitions. What is a force? A force is an agent or quantity that seeks to change the position or state of motion of a body. Grammar. Alright, so some people will say that a force is the interrelationship between two bodies. When two bodies interact physically, a force is said to exert itself. Now I would want you to get your jotters, your book, and then get a pen and jot this down. You don't want to miss it. And then speaking of force, what is a force? A force is also a vector quantity, meaning it has magnitude and direction. Now a vector quantity is a physical quantity that can be represented in both magnitude and direction. Now what is a physical quantity? Have you ever been out there and you throw a ball up and it has to come down? That is a physical phenomenon. Now whatever you can see in the physical, you can feel maybe the wind or a pressure on your hand or the sharpness of a blade. That is a physical phenomenon. As much as it can be measured, quantified and expressed, that is a physical quantity. Now let's look at the unit of the force. The unit of the force in the International System of Units, otherwise known as the SI unit, is the Newton. It is a derived unit named after Sir Isaac Newton in recognition of his work in classical mechanics. 1 Newton is the force needed to accelerate 1 kilogram of mass at the rate of 1 meter per second squared in the direction of the applied force. As you can see here, 1 Newton equals 1 kilogram times 1 meter, all divided by second square. Now let's look at the properties of forces. What are the basic properties of forces? Number 1, a force has a magnitude, and by that we mean it has intensity. You can measure the intensity. Now the quantity or intensity of forces can be represented by numbers. Yes, a force of 15 Newton is more in intensity compared to a force of 5 Newton. And then another property of forces is that they have a direction. Now a force has path or course of action which can be represented on a directional coordinate. Like can you see by the right hand side, you see the force F has a direction on the XY plane or XYZ plane, as we can see on the screen. Now you see the force has an angle with the X, that is the abscissa. It has an angle with the X axis alpha. It also has an angle with the Y axis theta. We will be discussing this as we move on. So other properties of forces are that it has a point of application. This is the specific location or place where the force interacts with the body. Remember I said another definition for force is that it is the interaction between two or more bodies. Now that part of the body where such interaction can be felt is called the application of the force on that body. Now a force also has a line of action. The line of action of a force is the line along which the force acts. Another property of forces is that they have a sense or nature. A force may act in any of the two opposite sides of its line of action. Now a lot of people get this confused with the direction of a force. Now a force can be acting in, let's say, north 32 degrees east. Now in that direction, it could be either to the top or to the bottom. We'll be seeing this soon. Let's take the effect of forces. Now a force has these, can have these and many more effects on a body. Number one, a force can change the motion of a body. Have you ever seen a ball rolling and then all of a sudden it comes to a halt even without somebody touching it? Yes, that's a force having effect on the ball. Now the force of gravity is, which we are going to talk about soon, is acting on that ball, and then it has the ability to change the motion. A force can change the state of motion of a body in different ways. For instance, it may initiate motion to a body at rest. It can retard or slow down a body in motion. It can bring a body in motion to halt, just like the football. Now another effect of forces is that a force can deform a body, meaning it can compress or expand a body. Now another effect of forces on bodies is that force can give rise to tension in springs, in struts, in belts and ropes. We are going to be discussing these individual elements one after the other in subsequent videos. Ensure you are still writing. We are just getting started. So let's look at the classification of and the examples of forces. Let's look at the classification. Now there are basically two categories of forces, namely contact force and non-contact force. Now if you can get a hand, or if you can understand these two groups of forces, then you have gone a long way in understanding forces. Yes, what is a contact force? A contact force is the force that needs physical touch. There has to be some form of union between the body that is bringing or influencing the force over the other body. For instance, you want to lift a cup, you have to touch the cup before the force that is being transmitted to your hand can carry the cup. That is an example of a contact force. Or you need to push a table, you have to touch the table. You understand? Then there is the non-contact force. Then these non-contact forces, they don't necessarily have to come in contact physically with such bodies as they are having effect on. And good examples of these are the gravitational force, electrostatic or electromagnetic forces, and nuclear forces, as you can see on the screen. Another classification of forces is due to the numerous number of forces we have, we can have other ways of classifying them. Let's look at some of these. Another way to classify forces is according to their effect on the body. A force can be said to be of an internal force when, for instance, you have pressure inside of a ball. Yes, that is having internal pressure, so it's an internal force. Then we have external forces, for instance, when you press on the body. Then we have active forces and passive forces. And furthermore, on classification and examples of forces, we have classification according to the nature of the force. You can have an action and reaction force, just like you can see by the right hand side. Then you can have an attraction or repulsion force. For example, you have magnetic interaction. And then we have the third one, tension and thrust. Still on classification and examples of forces, we have classification according to kind of loading. This is what we are going to be using very well in this course, so pay rapt attention. You can see the point load is just acting at a point, one single point. Yes, at that spot, that's where you can feel the effect of the force. And then we have distributed load. This kind of load is shared across the area where it is being applied, so it's not just at a singular point, but it is distributed along an area. Now let's look at the component of a force. Now when we say component, it means constituent, meaning what is making up another, the singular element you have making up a whole thing. Okay, so when we say the component of a force, we are looking at those simple things that make up a force. Yes. Now considering a force, like you see by your right hand side, considering a force F acting on a two-dimensional plane, XY plane, this force can have an effect on both the x direction and the y direction of the plane. The effect of the force F on the x direction plane is called the x component. You can see on the blue. Now it acts on the horizontal, and is denoted by F subscript x, while the effect of the force on the y direction is called the y component or vertical of the force F and is denoted by F subscript y. And now when these two component forces are acting at a point O, they will have the same effect as the force F acting alone at point O at a particular angle, say theta. Yes, the process of finding these component forces is called resolution of forces. Now from the diagram, to find f of x and f of y, we use the Pythagoras theorem, or what we call SOHCAHTOA. That's the acronym used for remembering it. Okay, therefore f of x is equals to f cos theta and f of y is equals f sine theta. Now still on the component of force, we can also compute this component using the angle alpha. This time we get fx equals f sine alpha and fy equals f cos alpha. Now in case you are having issues with how we were able to bring these formulas, f of x equals f sine alpha and f of y equals f cos alpha, then you have to watch our next video when we explained how these things came to be using the Pythagoras theorem. It's really easy, just watch the video and you will understand it. Now let's take our summary. I hope by now you can define and explain the term force. Remember, a force is anything that can move a body, change the shape of the body. Yes, that's a force. And then now you can explain the unit of force and the Newton. You know where it comes from. Sir Isaac Newton. And then you can identify properties of forces and their effect on bodies. And then by now I hope you can enumerate classifications and examples of forces, and I know you can determine the component of a force. Now on our next video we'll be looking at manipulating forces. In our next video we are going to be seeing how you can actually manipulate forces and make them do what you please just by applying standard laws. Yes, ensure you don't miss out. Keep learning, and until our next video, don't forget to like, subscribe and hit the notification bell so that you get notified whenever we put up wonderful videos like this. Thank you. From Brainbox, we say thank you for watching. Until next time.